Hi all, thank you for your interest in this work. My name is Chunggi Lee from UNIST, South Korea, and today I'm going to talk about GUICOM. This work is a collaboration between researchers at UNIST and IBM Research. Thank you for all of the co-authors and my advisor, Sung-Han Ko. As there are many apps with similar function, graphical user interface can play an important role in attracting users. Here we have two examples of online shopping mall main pages. The right one is the more clearer design and it has consistent layout. It can attract more users than the left one. However, it's not easy to make good UI design because of many design factors. For example, we need to simplify many information on the small size of screen. GUI design need to be visual pleasing and creative to give positive first impression to design users. One suggestion for producing high quality GUI design is to perform iterative design process, which is a cyclic process of designing, testing, analyzing, and refining in the design. While the idea of iteration design is simple and clear, doing the process can be hard if designs don't have any knowledge or have little design experience. For example, the novice in design can be easily overwhelmed by a blank canvas and may hesitate to rearrange their interface elements. They may have difficulties in conceptualizing design and harmonizing their design concept, and could make simple mistakes during their design. As such, there is a need to help this novice in design, and GUICOM is the first attempt to help the design novice in the GUI design domain. Our work starts from a semi-structured interview, where we interviewed novice users to find challenges that they may face during GUI design. Before we started the interview, we asked them to create a GUI design for a shopping mall with an existing tool, which is the KakaoOpen. After codifying the interview, we find three major difficulties. From the grounded theory, we identify three difficulties. First, novices are not good at conceptualizing design, so they have difficulties in starting their design. Second, they hesitate to fix their design, as they don't know which design elements are harmonized. Lastly, they do not know which part the viewers will see, so that they cannot design which design part to stress. From the interview, we derive three requirements for a system to help the novice. First, we need to resolve difficulties on the most up-to-date design in progress. This means the feedback for users also need to be updated to user canvas in less than 1 second. Second, we should ensure that difficulty 1 to 3 are met non-intrusively. Third, the tool can be attached to a web-based prototyping tool for generality. GUICOM is a GUI prototyping assistant tool for helping novice users perform iterative design process. The tool is a web-based add-on tool, work in real time, and provide multi-faceted feedback. Left figure is KakaoOpen. It contains thumbnail panel, canvas, and element panel. Thumbnail panel, which is A1, shows the GUI page that user created. A2 is the canvas where user can prototype GUI design by drag and drop GUI elements from the element panel. A3 is the element panel. It has the pre-designed button, text, and images. This is the GUICOM, and there are three panels for evaluation, recommendation, and visual input and feedback. The evaluation panel provides the quality of GUI using visual complex metrics such as element balance and alignment. GUICOM recommends high-quality example design based on what is being designed in the user canvas. Users also can filter recommended designs based on category and quality scores and acquire color information from example. The attention panel shows which parts or elements the viewers will focus. Let's see how our GUICOM works. As users make any modification on the canvas, the mutation observer JavaScript library detects the modification. Then the GUICOM sends the modification to server to process type and attribute of the modification elements. Let's see how each panel works to produce feedback in the next few slides. In this slide, we created selected HTML codes to have structure of images for the combination. First, we use the Ricoh dataset. It has 70,000 mobile app screenshots from about 9,000 Google Play Store apps, but we only used about 6,000 screenshots from about 2,000 apps after manual filtering. We then decompose the image into several elements have structure of each image. The structure are used to search examples for recommendation. To reduce the search space for recommendation, we use the autoencoder to complex image to latent features. There are two parts in the autoencoder, which is our encoder and decoder. The encoder complex the image representation to small latent feature, while the decoder complex the latent feature to the image representation. The loss function is used to minimize the different original image and reconstruction image. We use the KNN to find examples that are similar to what users is creating. As the user modified the design in the canvas, the recommendation panel calculates distance of current design on the canvas and the design in the dataset, and selects k-near images as shown in this figure. We use the mobile GUI evaluation metric proposed by Riegler Holtzman, which allows real-time processing. The inputs are HTML codes and the design on the user canvas. We slightly modified the original metric scale and their names to help users intuitively understand. For example, we changed the name of the element smallness to element size and adjust the 0.5 is the best score. This is an example metric for calculating element size. It calculates average element size and screen space and tell users whether the element size are appropriate or not. In the attention panel, we provide the user design on canvas, use the free convolution network model to solve the segmentation issue. The model complex image features conducts the convolution operation with features and reconstruct the complex feature for the deconvolution operation to make image segmentation. There are several free convolution models for different deconvolution operation points. For example, the FCN32 model reconstructs feature from 7x7 size feature, while FCN8 model reconstructs the feature from 14x14 size feature. The FCN16 model is more sophisticated than FCN32 model, so we use the FCN16 model to have better results. We have three research questions. First, does GUICOM help user make the design close to unacceptable design to general user than KakaoOpen? It is related on design quality. This means the novice users can reduce the basic mistake during the design process. Second, what is the UI UX benefit does GUICOM provide users? The last one is how do users use GUICOM's feedback to overcome the difficulties during prototyping? It means does the GUICOM perform iterative design process? To answer the question, we recruited 30 novice users and gave 2 tasks. The experiment was a between subject study where users are asked to design 2 user interface. The control group used the KakaoOpen only, while the experiment group used the KakaoOpen and GUICOM. We used an eye tracker for gaze analysis. After the experiment, the participants were asked to fill out post-experiment survey that include efficient fulfillment and effectiveness of GUICOM. We also measured satisfaction and preference scores. To investigate the quality of the produced GUI designs, we conducted a design evaluation session on Amazon MTurkers. In section 1, we recruited 26 MTurk workers for evaluating perceived design quality at 0 to 10 scale without rubric, which is general users' subjective assessment score. We recruited 21 other MTurk workers for evaluating design quality with rubric, which gives minimum guideline to online workers. The rubric was assessment criteria from the evaluation panel. The results indicate that GUICOM user produced design that are more acceptable to general users regardless of the task type corresponding research question 1. This figure shows dot and whiskers represent mean and 95% confidence interval respectively. The blue and orange mean KakaoBun and GUICOM respectively. The result was GUICOM help user make more acceptable designs in terms of perceived quality. There was no significant difference in the amount of time spent for design. The second result shows that using GUICOM is enjoyable, satisfactory, and affordable in terms of usability. We also find that there are significant differences in the satisfaction, efficient, fun, fulfilling, effective, and comfortable scores. Lastly, users employed multi-fast feedback for overcoming difficulties in the iterative design process. Gray, red, green, and blue represent gauge of users in KakaoBun, evaluation, recommendation, and attention panel, respectively. We think the interaction between recommendation and KakaoBun is prototyping. KakaoBun and either evaluation or attention panel is testing. Refining is the opposite direction of testing. From this gauge analysis, we see the many iterative design process. Our first finding was that users frequently use recommendation panel in the early stage until the middle stage. Also, users mainly use the evaluation panel in the later design process. Lastly, attention panel use the several stage. Lastly, the user enhanced the design quality after viewing the evaluation panel. Representative iterative design process was participant 3 found related on example and decide to follow the example below area. Participant 6 allow shows an interesting design pattern. After she was inspired by an example, she decided to use the sale promotion image such as 50% off. Once she put the sale promotion part, then she checked the attention panel if viewers will focus on the promotion image. Here are our lessons learned from our example. For we need to give additional feedback for why for justification. For example, when providing which part negatively affect the design quality or score can help user better accept the feedback. Another example is that participant 14 questioned why her overlapping design decreased the overall score, although she thinks overlapping design looks better to her. Lastly, users want to lead their design using creativity and would have appreciated with some automated collection. We designed it, implemented, and evaluated GUICOM to assist on users who have no and little design experience. GUICOM provides 3 types of feedback, which are dynamically updated as users continuously make changes in their design. The experiment result indicate that GUICOM allows users to create more acceptable mobile GUI designs with more fun, fulfilling, and satisfactory experience. This is the end of page. Thank you for listening.